tools and changing the HTML, you would actually write a program, a little PHP script like we did on Monday for doing spell checking in PHP, and you can simulate being a web browser. In fact, recall that from one of the survey from problem set 5, where we asked you guys to gripe about things that could be better on campus, one of the top contenders was this website here. Right, let's go back to a different browser here. Let's use Chrome. Was this guy here. It seems not they have a whole lot of information on this site when really all of us apparently only care about like what's in the menu, and even getting there sometimes takes multiple clicks. But there's a lot of news going on at HUD's right now. But in any case, we have, oh yeah, here we go. Case in point, this week's menu, hot entrees. OK, so here is the menu. And unfortunately, this is hosted, I think, by some third-party product that maybe Harvard has paid for. This is all HTML. And this menu changes every day because presumably HUD's has their own database. And so we could, frankly, as humans, just say, all right, well, I'm going to highlight and copy this. I'm going to paste this into my own database. Highlight and copy turkey noodle soup. Paste this into my own database. Or your Excel spreadsheet. And frankly, if you've ever done a research project or even something for a student group, there's probably some very tedious process you've done at some point involving the web that could have ideally been automated. And so what we actually do for CS50 is if you go to manual.cs50.net/APIs for application programming interfaces, you'll see that CS50 has a whole bunch of APIs. An API we'll talk more about next week, but again, it's a way of interfacing your code and your programs with someone else's code or someone else's data. And so every year we get very common requests for how can I make something related to the course catalog or events on campus or food or maps or news or tweets and the like. So what we as a course have done is created an API via which you can query CS50 server and get information like what's on the dining hall menu today or tomorrow or next week, or what was it a year ago today? What's the nutritional content? And so if you go to the the Harvard Food API from CS50, and scroll down, you'll see that there's a lot of detail on how to do this. But if you're familiar with Excel files, you might also be familiar with CSV files, comma, separated values files. These are just sort of simple spreadsheets. And so what you can do by visiting a certain URL that's there on the top right is you can provide a specific date. So in this case here, let me scroll down to the menu, not the nutritional one. So notice here that we have told folks that if you want to get the breakfast menu for a date of March 21st, 2011, you can literally visit this URL on CS50 server, food.cs50.net, and what you will get back effectively is a big CSV file, an Excel spreadsheet. And this is just what we're doing for problem set 7 when we grab data from Yahoo Finance. You're getting data back like this. But unfortunately, HUD's does not provide, like Yahoo does, a little download link. And so what we as a course had to do was, well, we opened up this page and we looked at view page source. And we ignored all the distractions up at top, and we started looking for patterns. And once we found a pattern like, this feels like patterns. Let's actually use Control F. So let's look for Chipotle corn bisque. Control F. All right, there it is. So here is the HTML in HUD's website. And notice that it's in a whole bunch of tags, some of which we've seen, some of which we haven't. There's some div tags, some image tags, and the like. But my God, like this is how the data is actually presented on the internet. So long story short, what we did as a course is we wrote something called a screen scraper. This is frankly a tool of last resort, but we have a program running on cs50.net that every day pretends to be a browser, like Firefox, goes to HUD's website, downloads the HTML, and it throws away the images and uninteresting stuff like that. And then we, quote unquote, parse all of this HTML. We look for TD tags, input tags, div tags, and then we look for patterns like, oh, this looks like a piece of food. And then we associate that back with the date and the meal and so forth. And long story short, we scrape all of this data into our own database so that we can re-expose this. Now, what's the relevance then to what we just did with the simple form submission? Well, it's very, very easy to pretend to be a browser. All you have to do is understand HTTP, understand HTML, and you can simulate all of this. And in fact, for final projects every year, we always have folks who want to grab like sports scores from ESPN.com or the like. So realize that in manual.cs50.net, there's a long article on how you can write your own screen scraper to get most any data you want from the internet in order to do analyses. People have done this with Facebook friendships and so forth to do research projects and the like, but realize that it is now within your grasp. So we've scrubbed our inputs, both for name, captain, gender, dorm. Now we have to construct a SQL query. So this query here is of this form: insert into table name, and then a comma-separated list of fields that we want to insert into, then values, and then another comma-separated list of the actual values we want to insert, and then that's it. MySQL query, passing in that SQL code, and voila, it's now in our database. So who cares? What do we actually do when it's in our database? Well, think about what we could now do. We could whip up a little script for a proctor, and we could say something like this. And I'll just do a cursory form of this. Let me go ahead and do registrants. Oh, oops. Let's do open PHP mode, close PHP mode, registrants. Actually, let's just open this one. Whoops, not that. Let's just open this one, and voila. It's already out of the oven. The program now will look a little something like this. So connect to database. Same exact thing up top. We connect with localhost jharvard and Crimson to that specific database called week9. Notice then my SQL query. I just create a variable called $SQL. I store in it what's apparently another SQL query. And this one follows the form select field names. So I could do name, captain, dorm, gender in any order, or a little more succinctly, I can just say star, which is the wildcard operator, from the table name. I could write this in lowercase here, but it's, as a matter of style, it's, I would say, easier to read when at least your special keywords are all in uppercase. However, realize this, FAQ, table names and field names should be case sensitive. So if you capitalized it in your database, do it that way in your code, and then execute this query. But here's a common sticking point. When you execute this database query and you use the select command, what do you actually get back? Well, inside of the database are these tables, right? Like Excel worksheets. So what you're getting back is not some one person's name and gender and so forth. Rather, you're getting back what we'll call a result set. Think of this as an array of rows from the database. So if we scroll down here and we actually want to write this page that's supposed to show the proctor who's in charge of Frosh IMs who has registered, notice we actually have to ask this result set that we got back from MySQL query, which is up here, give me a row, give me a row, give me a row. And we can do that with a while loop. We can say while there is a row to give me. So this function, MySQL fetch array, when passed a so-called result set, a collection of all the rows in the database that match that select query, go ahead and assign one at a time to a variable called row. And then I can get at the individual fields in that table by doing $row, open bracket, quote unquote name, close bracket. So based on this syntax, what type of variable or what type of data structure is row at this point in the story? Yeah, it's an array, but more specifically, it's an associative array, right? It's an array that can have not just numeric indices, but words as its keys. And so what's this going to do? Li is list item, ul is unordered list. So let's just jump to the aesthetic results here and go back to registrants.php. This is going to talk to that same database. Let me go into registrants, and voila, David has registered. Well, it's not all that interesting right now. Let's go into register, let's say 8.php. Let's actually register Matt this time as the team captain from, I don't remember where he lived, so we'll say Applicourt. Register. OK, Matt is apparently registered. Well, let's check. Let's go back to registrants.php, and now we have Matt. And then we could have another person. And we can now see this. If I open up my little administrative tool called phpMyAdmin, and I log in as jharvard and Crimson, I then get to see this sort of web-based interface for all these tables, one of which is week9, registrants. And if I zoom in here, notice that despite all the messy words and icons, there's David, there's Matt. And if I want to go around here and even modify things, say Matt actually wants to change his name, this is not something Matt himself should do, but you as the administrator could certainly change a row, which then has the effect of changing the actual table. So now we have the ability to store data as long as we want. And frankly, not to sort of set the expectations too high, I mean, this is at the core of what even Facebook did early on. You have someone register. You ask for their name. You ask for their residence. You ask then for them to list off their friends and so forth. You can do all of that simply by creating these tables and storing that kind of information. And anytime you have something conceptually different that you want to store, say user profiles and friends and likes and activities, you can have a different MySQL table doing doing all of that. And recall from problem set 7 that we don't just store users' usernames and their hashes of passwords. What other field is also, by default in pset 7, associated with each user? Oh, what's that? So not just money, but an ID specifically. So here's the users table, recall, that you get for pset 7. You have all these usernames and these hashes, which are hashes of passwords. But we also gave everyone a unique ID. And if you read through the pset spec, you'll see that this ID is auto-incrementing, which means I, in code, do not have to generate or figure out what the next number should be. The database will do that for me. So Facebook did the same thing. Some of you who have never signed up for nicknames for your URLs might have facebook.com/profile.php ID equals 1, 2, 3, 4, 5, or some number much bigger. That's because all of us have unique Facebook IDs. And you can actually infer from those IDs who's been on Facebook the longest. The bigger your number is, the later you signed up. So there are certainly folks. So this is really sad that I know this. I am number 6,545. That was apparently the number in which I signed up. Mark, I think for some reason, his ID equals 3. And then there's also some familiar names if you poke around the Facebook API where you can see everyone's IDs. But long story short, why have IDs for users when we already have usernames, which themselves are supposed to be unique? Caesar, Chartier, Guest, J. Harvard. Why have IDs at all?
It's much easier to index ints than
What do you mean index ints?
go on the database so you can find them faster because they're ordered by number.
Perfect, right? So it actually is for performance reasons. Caesar is it's a short word, but it's 1, 2, 3, 4, 5, 6 characters. J. Harvard is slightly more. R. Bowden is a few characters as well. That's a bunch of bytes. And certainly for longer usernames, like some of you have for your @college.harvard.edu accounts, that suggests that you have to do string comparisons a lot. Strcomp, if you think back to the C function. It feels like it should be much faster if you instead give everyone a unique number, like an integer. Then you're using only 4 bytes or 32 bits. And plus, you can then sort things numerically. You can create, as we've seen in class, more sophisticated data structures like linked lists and hash tables and the like that store those numbers. And so indeed, storing ID numbers that are ints or something called big ints, which are 64-bit integers, tends to be the best way of storing your data, so that then if you want to list for, say, Caesar, all of his friends, you can have another table. And let's whip something up here. I'm going to go ahead and create a new table for pset 7, which is irrelevant to pset 7, but we'll use the same users, called friends. I'm going to give this 2 columns, enter. And the first column I'm going to say user A. And over here, I'm going to say user B. And if I give these guys both integer types, the idea here is that if I want to associate users with other users to form symmetrics, whether symmetric or asymmetric, all I have to do is say that Caesar, for instance, is friends with who was number 2? Well, whoever number 2 was. So if I want to say that Caesar and Matt are friends, all I have to do is store in this table 1 and 2. And as you'll see before long, there are ways to then join these tables. So long as you have one field in common, like an ID field, you can actually figure out or look up users in one table whose IDs are already in another. And in fact, even CS50's own course shopping tool, we have this notion of what your friends are taking or shopping in the way of courses. This is literally what we do. When you sign in to Harvard Courses using your Facebook login, one of the things Facebook gives us, because we're using their API, is a huge array of all of the IDs of all of your friends. And we can then use those IDs to look up your friends' names and profile